Okay, in this section we're going to talk about 4-1, how to identify a linear function based on certain criteria. In this particular section we're going to use this graph, but this can apply for any graph. So for instance, if you look at is this graph a function, question number 1, you simply have to do the vertical line test, which just draw a vertical line and count however many times it crosses the graph. For instance, if you had a graph that looked like this, it only crosses one time. But if you had a graph that looked like this, when you drew a vertical line, it would touch in this spot and this spot. So that would not be a function. So each one of these touch one time, therefore it is a function. And then it says explain how you know it's a function. Well, again, it passes the vertical line test. If this graph is a function, is it also a linear function? And the answer is yes, because we can clearly see that it creates a straight line. Now, what does that mean in the scheme of things? It means that if we can show that the slope is the same at various points, like if I were to do this, just do this slope right here, and then do another slope, and then I would look at the ratios of rise. So I went down, so I went from 4 to -2, that's a drop of 6. And then I went from -6 to 0, that's a run of +6. So -6 over 6 is a slope of -1. Same thing here, if I go from -4 to -10, that's a drop of -6. And then if I go from 2 to 8, that's a run of 6. So rise over run, and again that's also -1, and you can tell that both slopes are the same. Therefore, that's how I can determine whether or not it's a linear function. On this next section, we're going to look at these ordered pairs. And some of the questions, does the set of ordered pairs satisfy a linear function? Okay. Remember, for it to be a function, x's can't repeat. Alright, but in order for it to be a linear function, we have to check the slopes. And then we're going to talk about standard form next, and then we're going to learn how to graph it. Okay, so first let's look at the coordinate points. So let me bring these over here, and I'm going to make a little t-chart. And then it's 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And then of course 8, 6, 4, 2. So 8, 6, 4, 2, and 0. Let's check the slopes. Now remember, in order to find a slope, it's y minus y over x minus x. So it doesn't matter which direction you go. I'm going to do this. So 8 minus 6 is 2. Same direction, 1 minus 2 is actually -1. So when you have a rise over a run, you get 2 over -1. Now let me go ahead and get this out of the way. Alright, so this one right here, I've already done one slope. So let's do another one. Let's do 4 minus 2. 4 minus 2 is 2. And then of course 3 minus 4 is also -1. So again, this is my rise, or my change in y, over my run of -1. And you notice they're both the same. Let's do one more. Let's try to get rid of all this. And let's try a different one. Let's try, let's see. Let's do 6 minus 2, and that's 4. And let's do 2 minus 4, which is -2. So again, rise over my run of -2. Now, it might not look the same as these two, but let's go ahead and try to reduce. If I divide by 2, I end up getting 2 over -1, which is exactly the same as these. So how did I decide? By finding various slopes of the coordinate points and then comparing them. Now, we're going to take that equation, y equals x minus 4, and what we're going to do, let me move all this out of the way. Well, let me see if I can. Alright, let me move this over here. Now, what we're going to do is we're going to take this equation and we're going to put it in standard form. Now notice, ax plus by equals c. X and y are on the same side. Well, we got to take our equation and make it look very similar to that. So our equation is y is equal to x minus 4. Let's move x to the other side because I got to get x and y on the same side. So if I subtract x and put an x over here, now be careful. It's not. You can either write y minus x, or you simply put the x in front, negative x. Y is positive, so we're going to add the y and then bring down your negative 4. Now, ax plus by. Notice that this is positive. So what I want to do is I want to make this positive. So I'm going to divide everything by negative 1. And what I end up getting is positive x minus y equals positive 4. Now, my a in this case is going to be 1. The b in this case is going to be negative 1. And c is going to be 4. And now it's in standard form. So x minus y equals 4 is standard form. Now, the last thing we're going to do is we're going to graph it. So again, we have y equals x minus 4. The minus 4 is my starting point. So find negative 4 on the y-axis. That's called the y-intercept. Remember, y equals mx plus b. So my b in this case is my negative 4. My m is the number in front of x. So that's a 1. Or 1 over 1. That's my slope. So I'm going to go to the next point. Up 1, right 1. Alright? And then I'm going to up 1, right 1 again. So I'm following my slope to get the next point. So up 1, right 1, and I keep making these connections, and now I can just connect the dots. And there's your equation. Graphed for you. Okay, in this particular problem, it's a word problem, and you're going to have to graph this function and give its domain and range. Now, the domain and range has to make sense. Like for instance, since this is talking about snowing, notice the graph. It goes all the way up to 20 hours of snowing. Okay, so how many inches of snow can I have in 20 hours? Well, it's hard to say how long it will continue to snow. So let's give a reasonable domain. Let's say the graph, it could snow for 20 hours straight. So in that case, let's just go ahead and play with that. And my domain for right now is going to be between 0 hours and 24 hours. Or let's say 20 hours. Alright? So if it snows for 20 hours, let's figure out what the range is that goes on with it. So it's going to be greater than or equal to 0 or less than or equal to 24. Now remember, this is talking about our time. Now let's talk about our range. This is the amount of snowfall. Well, if I have 2.5 inches of snow every hour and it snows 0 hours, well, the only thing I have to do is replace that x with a 0. So 0 hours, 0 snowfall. And I know my snowfall, which is my y value, is going to be greater than or equal to that amount. Now, let's figure out what 20 hours of snowfall would give us. So I know that the y is going to be less than or equal to that. So let's do that. Let's do 20 hours times, oh, sorry, wrong way of doing that. Let's take 2.5, plug in 20 hours, and that's going to give us 5. Or sorry, 50. So 50 inches of snow. Wow. Alright, so we're going to put 50 here, and we're going to close it up. So if it snowed for 20 hours straight, at this same rate, we would assume, or we would expect around 50 inches of snow. Alright? So now, how do I graph this? Well, just like I did, we're going to create a table similar to what we just did here. Alright, so let's create a vertical table. So here's my x, and here's my f of x. all right? And we're going to create some coordinate points. So when x is 0, when x is 1, when x is, oh, let's see, let's do when x is 2, let's do when x is 4. All right, just to do a couple. When I plug in 0, 0 times 2.5 is 0. Oh, let me give you some more space there. All right, is 0. So that gives me the coordinate point of 0, 0. When x is 1, 2.5 times 1, that gives me a snowfall of 2.5 inches. So in 1 hour, 2.5 inches. Now, let's try 2. 2.5 times 2 gives me 5 inches of snow. And 2.5 times 4 gives me 10 inches of snow. So when I plug that into the graph, I'm going to plug those points. So at 0, 0, that's easy to mark right there. Now 1, 2.5 is going to be just about right there. So not very clear where it should or shouldn't be. Now 2, 5 is going to be just above the 4. And then 410 is a little bit clearer. It's on this point here. Now if you notice, it gives me a straight, seemingly a straight line that I can connect those dots. And by that, using a prediction line, I can actually predict how much it will snow depending on how much or how long it snows.